So let's take a few values like 0, pi by 4, pi by 2, 3, pi by 4 and pi. So for these values, I'll put these values here in place of omega and then evaluate for mod h of omega. So this is how the values of mod h of omega will come out to be. When you put omega equal to 0, cos of 0 becomes 1. 5 by 4 plus 1 will be 9 by 4 and square root of that will be 3 by 2, which is 1.5. And likewise, when you put omega equal to pi by 4, pi by 2, etc., you get all these values. So you can see it starts from 1.5, and as omega reaches to its maximum value, which is pi, in that case, mod of h of omega will be 0.5. So if we plot mod h of omega, this is how it will look like. So on the x-axis, we will take omega. Omega varies from minus pi to plus pi. Even though we have found mod of h of omega from 0 to pi, as I just now told you, it will be an even function. It will be exactly same between 0 and minus pi. That is simply because cos of omega is an even function. So mod h of omega also becomes even function. So if we plot this, you can see, let's say this is 0.5, this is 1, and this is 1.5 scale. So in that case, at omega equal to 0, we have the maximum value of 1.5, and then it reduces towards 0.5. So my mod of h of omega will finally stop at 0.5 at omega equal to pi and minus pi. So this is how the frequency response will look like. To be precise, this is the magnitude response that we have drawn. And you can see that from by looking at this magnitude response, we can easily make out that the nature of the filter is nothing but low pass filter, because it allows the low frequencies to pass. That means it gives you high amplitude for low frequencies, and for high frequencies the amplitude will be less. So that becomes low pass filter. So the first filter that was given to us is nothing but a low pass filter. One can also find the phase response. Phase response is nothing but angle of h of omega. Angle of h of omega in this case will be tan inverse of imaginary by real. Imaginary part is half sine of omega divided by the real part is nothing but 1 minus half cos of omega. So one can also find out the various values of the phase response for values of omega that we had taken for magnitude response, and we can also plot the phase response. However, the nature of the filter only depends upon the magnitude response. So we got the first answer that the filter in first question was nothing but low pass filter. Let us now identify the filter given in this second question in the form of system function.